You ever wonder how the exact same virus can totally knock one person out with a fever and a cough, but their friend gets it and just feels, well, a little weird? It is a genuine medical mystery, and it's exactly what we're going to unravel today.
So, let's really set the scene here. Imagine two people get hit with the flu. Person one gets the absolute textbook case, sky-high fever, body aches, the whole 9 yards. But person two, maybe an elderly relative, suddenly just gets really confused and weak, with no fever in sight. Same virus, but two wildly different diseases. How on earth is that possible? Okay, to get to the bottom of this, we've got to get two key ideas straight. On one side, you have sporadic cases. Think of these as the lone wolves, the individual, isolated illnesses that just pop up here and there. On the other side, epidemic cases. That's the big one, the widespread outbreak that tears through a whole community. The answer to our puzzle is buried in the differences between these two.
Right, so our first major clue, it actually has less to do with the germ itself and everything to do with the person who gets infected. It's all about the host.
And here is the first huge distinction. Sporadic cases, they often show up in a really diverse bunch of people, usually older folks, people who might already have a few other health issues going on. Now, epidemics, on the other hand, they tend to burn through younger, healthier, and much more similar groups of people. Just this one difference, who gets sick, is a massive piece of the puzzle.
Let's dig into that a little. First off, as we get older, our immune system naturally starts to quiet down a bit. It's a process called immunosenescence, and what that means is the body's main alarm bell, a fever, might just not ring. Then you've got other illnesses, what doctors call comorbidities. If your body is already dealing with heart disease or diabetes, its response to a new infection can get totally scrambled. So a nasty bug might show up not as a cough, but as sudden confusion or even a fall. And of course, there's our own unique DNA, our genetics, which plays a giant role in how we each individually fight off a germ.
Okay, so the patient is one huge part of the story. But let's move on to our second clue. Because it turns out the pathogen, the germ itself, isn't always the same predictable bad guy.
Think about it. An epidemic is usually driven by one single dominant strain of a virus or bacterium that's just incredibly good at spreading. It creates a very clear, predictable pattern. But sporadic cases, they're the wild card. They can be caused by a whole grab bag of different strains. Some are new, some are rare, which, you guessed it, leads to a much wider and more unpredictable range of symptoms.
So here's the bottom line on this point. An epidemic is like a single artist painting the same picture over and over and over. You learn to recognize their style instantly. Sporadic cases, though, are more like a gallery show with dozens of different artists. You're going to see a huge diversity of styles, and no single one defines the whole exhibit. That diversity in the germs leads directly to diversity in the symptoms.
All right, we've looked at the person, and we've looked at the pathogen. For our third clue, we're zooming out to look at the world around them, because where and when you get sick can change absolutely everything.
I mean, the environment itself plays this massive role. Something as simple as the temperature and humidity can decide whether a germ thrives or dies. And where you are on the globe, oh, that really matters. The flu might be a winter thing in Chicago, but in the tropics, it can be a year-round problem. Then you have social factors, everything from how close people live to each other to how easy it is to see a doctor. All of that can be the difference between a single sporadic case and a full-blown epidemic.
Now, this last clue is really fascinating because it's not actually about biology. It's about us. It's about how the very act of looking for a disease changes what we end up finding.
Just think about it for a second. The moment an epidemic is declared, it's like a giant, powerful searchlight gets switched on. Every doctor, every hospital, every public health official is on high alert, and they're all looking for the exact same set of symptoms.
The entire system just snaps into high gear. We are actively hunting for cases. The moment one is found, it gets reported at lightning speed. That textbook case is front and center in everyone's mind.
But now, flip that coin. Think about that one-off, sporadic case. The searchlight is off. The system is quiet. A doctor sees an elderly patient who's just confused. Is the very first thing they think of influenza? Probably not. Why? Because it doesn't fit that classic picture. Clinical suspicion is low.
And this all leads to something called diagnostic and reporting bias. Now, this doesn't mean anyone's doing a bad job. It's just that our healthcare systems are built to recognize the loud, obvious patterns of an epidemic. Those quiet, atypical, sporadic cases can easily slip through the cracks, getting misdiagnosed or just diagnosed way too late, simply because they don't match the pattern we're all trained to look for.
So, we've gathered all our clues: the patient, the pathogen, the environment, and the system itself. Now, let's put all the pieces together and finally solve this thing.
And here it is, the whole story, all in one place. You can see how perfectly the textbook epidemic case lines up on the right. A younger host, a single dominant germ, predictable conditions, and a system on high alert. And the puzzle of the sporadic case is the polar opposite on every single point. A more complex host, a variety of germs, unpredictable local factors, and a system that isn't really looking for it. It's the combination of all these factors that creates two totally different diseases from the exact same bug.
And this really hits the nail on the head. It's not one thing. It's the complex interplay of everything, the person, the bug, the world around us, and even our own perception that creates this massive difference.
So, why does any of this matter? Well, for doctors, it's a huge reminder to look beyond the textbook, especially when treating older or more complex patients. For public health officials, it means we need to build smarter surveillance systems that can catch these quiet, atypical cases, because that's very often where the next big outbreak gets its start. And for you, for all of us, it's just a powerful reminder that disease is never, ever as simple as it seems in a book.
And that leaves us with one last big idea to chew on. In a world where every single person is unique, and as our populations get older and more complex, we have to ask ourselves, is that classic textbook case of a disease we all learn about actually becoming the exception and not the rule?